Yeah, so the sharing will start at 10 and people just coming right now. And just
Awesome.
for, yeah, for your knowledge, so we are Web3 Build Tech and we are like study group for everyone to share the Web3 knowledges here. And we
Awesome.
have Monday and Friday sharing. Yeah. So today is for deep dive. Yeah. So every week we invite like one high quality project to
Awesome.
introduce your, yeah, yeah. So yeah, glad you are here. So I think yeah, we just wait for more people and we can start now. Yeah.
Awesome.
So
That sounds
thanks
good.
everyone. Yeah, thanks everyone for coming. So this week's deep dive, we have invited Marcus, his developer relations at the Graph. He will give us a sharing on how to develop and query subgraphs on the Graph network. Yeah, let's start.
Awesome. Yeah, well, thank you so much for having
Sure.
me. And hi, I'm Marcus. I work with Edge and Node, a core development team working on building the graph. And in this workshop, if anyone has any questions at any time, Yo-Yo, if you wouldn't mind, I'm going to be sharing my screen. If someone types a question in chat, feel free to just go ahead and say, hey, Marcus, there's a question. I'm happy just to answer questions as we're going along here. I want this to be interactive and I want this to be enjoyable for everybody. So, not just me talking the entire time. So, if anyone has a question, feel free to throw it out there. We're happy to chat
Sure,
for
sure.
this. So, let me go ahead. And first, what I'm going to do is I'm going to share. We're actually going to go through two workshops today. We're going to start with a workshop that's specific to understanding the graph from a high level and how to interact with the graph from a high level without having to build necessarily a subgraph. And just to start with that, I think that's a good place to start. Who here, by the way, knows about the graph? Are there a lot of people that know about the graph in this chat, or is it new? I'm just curious what the level is here. Let's see. Feel free to hop in chat right there and just let me know. Do we have beginners? Are we intermediate? Are we advanced? Is the graph new? Is it? I'm just trying to understand. The graph is new. Okay, the graph is new. Is the graph new for everybody? Okay, sure. We know the graph. Awesome. Awesome. Okay, so new plus one. Okay, so it's a mix of those that know the graph and a mix of those that don't. So that's good. We're going to start with this first repo, the subgraph query workshop. I did this last year and it's still holding true. I'm going to update it a little bit, I think, in the next few months. But right now, it is going to be holding true for what we are working on today. If you want to open up that repo, you can. And in that repo is actually going to be the workshop we're going through, as well as a few of the things that are going to be useful for us today. So let's go ahead. I got to change system settings here to allow. There we go. Ba-bump, ba-bump. Okay, so what's going to happen is I'm going to have to quit Voove and then I'm going to rejoin in just for this presentation. Okay, so I'll be able to share my screen with this. Does that sound good? I'll be right back. 1 second.
No problem. No problem.
Okay,
We can wait.
cool. Mm,
大家稍微等一下，就是 Marcus 他可能那个就是设置的问题，他要退出一下再进来才能共享他的屏幕。
okay, we are back. Hi, everyone.
Hi, yeah,
I'm going
still
to
here.
share. Yes. And I'm going to share my screen now. All right, let's go ahead and get into this. So what we're going to start with is querying Web3 data with the graph. So getting Web3 data as a whole is something that we like to do as builders and build some very cool stuff. The Web3 blockchain is all accessible. And how do we get that data? And how do we go ahead and use that data? Well, that's what this presentation is about, and also understanding that with the graph. This QR code, that's the link that I sent you, so you don't have to scan that. This repo that I sent you will allow you to basically drag and drop code into your decentralized application and query the graph network. All you have to do is find a correct subgraph endpoint, which we'll talk about, and then also create your own API key, which we'll also talk about. And there's also, with that repo, there's different ways that you could, of course, query the graph. You could use vanilla JavaScript, Python, Apollo, and also there's a library called Graph Client, which the Graph is very proud to be developing all the time, and it's specific to querying subgraphs on the graph network. We'll also talk about playgrounds and Python, as well as DAppLooker in this presentation too. But you have that repo. All of this will be for you. So let's go ahead, and I love this quote. Let's read this here. It is not the answer that enlightens, but the question. And I really connect with this quote. This is from Eugene Ionesco, who wrote Plays many years ago. I think curiosity is my favorite emotion. When I feel curious, I feel energized. When I feel curious, I feel motivated. And then from there, when I'm curious, I want to go find answers. And that's really what the graph is about. It's about saying, okay, let's all be curious about crypto, about Web3. Let's go find answers and let's go ask some really good questions. And that's what this presentation is about. And the graph is there to help us answer those questions. So why is the graph important in this? Let's go figure that out right now. What is the graph? This is part one. So the graph is, let's step back a little bit before we go into the graph. Let's talk about blockchain. So the blockchain, all the different blockchains out there, they're all very much write optimized. When we first get our wallet, first interacting with the blockchain, we're always writing transactions. We're learning about gas fees. We're learning, okay, well, when we write, how do we mint, like all these different concepts. What does that mean? We don't really consider too much about reading from the blockchain. And that's the case in terms of the blockchain. The blockchain was really written and created as a technology to store information. The read problem with this is that it's very disorganized information. Anyone who writes to the blockchain in terms of the timing might be in this block. I might write some information to this block, and then 2 months later, I also use that same smart contract and I write to this block, and it's completely disorganized. So indexing is required. So indexing being the organizing of all this data. So that really is the read issue with the blockchain. How do we organize data that's being written to the blockchain that's really disorganized? And that is going to be the indexing that we have out there. So with indexing, unfortunately, there's a lot of centralization problems with indexing in that we have all the blockchain, and to make that data organized, we have to run it through a centralized indexer potentially. And that could create issues where we have wonderful decentralized data on the blockchain, but it's really being we're running into problems with that. We're saying, hey, we have amazing Web3, but let's go run through a centralized indexer and have the same problems of Web3. And that's really what a lot of competing companies out there are doing. The graph as a whole is not doing that. The graph is a decentralized indexing and querying protocol where we have indexers around the world permissionlessly indexing data from over 40 different blockchains. And they're doing this incentivized by the GRT work utility token. It's not done by people who are, going and applying for a job. This is anyone, you, me, anyone out there could go and become an indexer in the graph network and organize this data. If you know how to index and you know how to run a database, you know how to serve queries, you could become an indexer and actually start getting returns in form of the GRT token. It's a work utility token meant to incentivize the indexers to index the data. So when we have one indexer on the graph network, there might be 20, 50, 100, 150, and they could all be there for us in case any one of those indexers goes down. There's another backing them up. And that's a really cool thing about the graph network. There's a lot of redundancy. There's permissionless. It's really fast, cheap, and reliable. Right now, it's $40 per million queries on the graph network, which is really, really affordable and highly competitive in the Web3 space. And it's really open to the world. Anyone that has any of this data in the world can actually query these endpoints. And there's over 2,500 endpoints in the graph network as a whole. So that's just a high-level overview of the graph. And before I go on, I want to talk about the next step deeper into the graph. But I want to ask, are there any questions? Have there any questions come up? If there's any questions, just put them in chat and, feel free to throw them out. No questions right now? Cool. Let's keep on going then. Yeah, put them in chat and feel free to interrupt if there's any questions. I can't see the chat window right now. So anyways, so subgraphs, what are subgraphs? Essentially, if we remember this image before, these are all the blockchains and these are all the indexers right here. And this is our front end. This is the computer. Make the screen a little bigger for us. There we go. This is, reading from the front end from our browsers. Subgraphs are customizable APIs. If we look at this little arrow, these little arrows right here, essentially, they are how we get data organized in these indexers. We send these indexers these instructions in the form of subgraphs. And then from there, our subgraph becomes that organized data set that we can go ahead and send our queries to. So each of these little arrows represents little subgraphs, and we can design those. That's really important that we give indexers these instructions on how to organize this data. And then from there, we can query that subgraph or the API. And then also in the graph, subgraphs are valuable because, like I said, it is incentivized by the tokenomic model that involves the GRT work utility token. So the indexers are incentivized to index these subgraphs, and then also subgraph developers and people out there who are just wanting to get involved in the graph can actually use the GRT work utility token to show which subgraphs are valuable by putting the GRT token on the subgraph itself. And then from there, people can earn returns from that. So pretty cool to actually say, hey, these endpoints are valuable in the actual space. And I love this GIF here just to really point it home. Subgraphs are customizable instructions. We can develop subgraphs. I'll actually be teaching you guys how to develop subgraphs on your own in the next workshop. We're not going to do that in this one, but this is a good example of what a subgraph is doing. It's taking disorganized blockchain data at the top and running through itself and then putting it into nice organized buckets to be queried. And that's very nice because anyone who has tried to have a database that's unorganized and actually work with it, it's very challenging. So having good indexing of that database is critical. And that's really what a subgraph does. These are some of the files in the subgraph. We have the manifest, which is the subgraph.yaml file, the logic, which is the mappings.ts file, and then the schema.graphql file, which is the database, how the database is being organized. And it's also getting past this on-chain data. 40 plus chains are supported, and there's also off-chain data, which is IPFS data and Arweave data, which also is able to go into the subgraph, which is pretty cool. More off-chain data is being supported all the time, and then also on-chain data. There's more chains being supported all the time. So we're really expanding this source list over time. But really, in this presentation, we're just going to be looking at the schema.graphql because we want to query a subgraph. Each subgraph has a database in it. And then from there, we want to send our queries to the database in an appropriate way. So we'll eventually, in the next presentation, get to the logic and the manifest. But right now, let's just take a look at the schema in this presentation. And remember, I said the subgraphs are valuable. These subgraphs are on the Graph Network, and we could see which subgraphs are in the Graph Explorer. And anything in the Graph Explorer is on the Graph Network. So we'll go over that and see, okay, how can we explore the Graph Network? Let's see what's decentralized. Let's go ahead and dive into that. We'll do that in a second. And that really is a summary of the Graph Network and the graph as a whole. It's got 150 indexers worldwide currently. Sometimes that number goes up to 400, sometimes down to 100. It ranges depending on if it's a bear or bull market, and that's just the nature of Web3 as a whole. There's 40 plus chains, and right now, I actually just checked earlier, there's 2,500 subgraphs available for querying. So we are getting more and more subgraphs available all the time on the Graph Network. Each of these endpoints are available for you to start building. It's pretty cool. So let's go ahead and dive into the Graph Explorer. We'll start exploring what's on the Graph Network, and then we'll actually run through some steps to query a subgraph. So the first thing what we're going to do is set up an API key. The next thing is we're going to find and assess a subgraph that's on the Graph Network, and we'll go through the Graph Explorer to assess a subgraph. We'll design some queries. We'll ask some good questions of that subgraph. And then finally, the last part was integrating that query with the dApp. That's something that you guys can do with that repo that I sent you. If you find any queries that you design or I design that you like, you can just simply drag and drop into that repo and then take that into your application. So pretty cool. Excuse me. So let's go ahead and set up an API key. All right. So we'll go ahead and go to thegraph.com. And from here, we will go to products and then Subgraph Studio. And I'm going to connect the wallet. Okay. And then we'll go to the top here, API keys, and then we're going to create an API key, and we'll call this a live demo API key. And there it is. So with this API key, we can now use this to query the Graph Network. With the Graph Network, there's 100,000 free queries that we can have per month. So it's really nice. If we're just trying to learn about the graph and not wanting to pay right away, that's totally fine. We get 100,000 free per month, and you can just go ahead and start copying that and using that to query the Graph Network. One really quick thing here is I want to go to the security tab. Just good to know. If you ever want to restrict your API key to a specific subgraph, you could use this one here, or to a domain. You could restrict your API key to a specific domain. Really nice security features to make sure your API key is not being an attack vector and potentially getting drained. We don't want to see that. So how do we use our API key? Let's go into the Graph Explorer and start exploring the Graph Network. So here we have the Graph Network. As we can see here, there's 1,800 subgraphs currently published on Arbitrum One. This is a tab to look at the GRT work utility token on Arbitrum, and also we have it on Ethereum. The token is in 2 locations. So depending on where that token is incentivizing indexers, we have subgraphs. So there's just about 1,000 subgraphs on Ethereum right now, and on Arbitrum, there is 1,800. So yeah, 2,800, almost 3,000. Pretty cool right there, amount of subgraphs. So let's go through a subgraph and just kind of understand, well, how can we send a query to the subgraph? Let's go check out the subgraph right here. Let's click on one. And from here, we can say, all right, well, if this is a subgraph right here, we can go ahead and just really quick overview, go to the playground, and we can go ahead and start sending some queries to this subgraph. No big deal by going to this location and designing GraphQL queries with this over here. So if we look at the different factories, we'll go into this later in a little bit, but really what I want to show quickly is go to this button here, where this is the endpoint. This is this subgraph's endpoint. And you see right here, it has an API key. That's where we would copy this query URL and drop our API key into that location, and we could start sending queries that we designed from here to this location in our application. So really quick to overview that. Now that we've set up an API key, now that we've kind of getting an overview of the subgraph's dashboard, what I want to do is dive a little bit deeper into the graph as a whole and kind of like go through a step-by-step and how do we assess a subgraph's quality? Okay, so how do we get to the point where we're looking at the subgraph, we understand everything that's going on here, and we actually want to send some queries, and we know what data we're going to get back? Let's go through a step-by-step on what we can do with that. So the first thing that I like to do is understand, is this subgraph a Messari standard subgraph? The next thing I like to do is look at the curation level. The next thing I like to do is look at the documentation. And finally, I like to look at the schema.graphql comments. We're going to do all of this right now. Since we have 25, now 2,800 subgraphs on the Graph Network, how do we assess what's good, what's bad, what's useful to us, what's not? That's what we're going to answer right now. So let's go ahead and go back and see this list: Messari standard subgraph, curation, documentation, and schema.graphql comments. A Messari standard subgraph, to start, is a subgraph that has this Messari tag on it. I'll make this a little bigger. See this Messari tag? Messari. Messari is a core development team working on building the graph. So I'm working with Edge and Node, which is another core development team. This is a core development team that's responsible for building high quality subgraphs with a lot of features, with really good documentation. So as soon as you see a Messari subgraph, you know it's a well-designed subgraph. And because we know that, we can trust the data is being handled well. It's got good documentation. We can click into this and just take a look around briefly, and just start to understand, all right, well, let's see this subgraph and just say, yep, we have access to the GitHub repo for this subgraph. We could dive in if we want to. We have a link to Messari.io to read more about the subgraph. It's got different entity types nicely labeled. It's got some good indexing. We've got 9 indexers on this. This is a high quality subgraph. Now, one other thing that you should know about Messari subgraphs is if we go to subgraphs, .messari.io. This is Messari's dashboard for all the subgraphs. So if you ever want to go to really high quality subgraphs and really understand, okay, how can we see all the Messari subgraphs possible, this is the location to go to. So when we go to this Messari, I'll show you the let's open it here. This is subgraphs.masari.io. That's available, or it could be subgraphs.xyz. Both are domains that are used. Every one of these subgraphs have nearly identical databases and nearly identical schemas. All right, and we'll go into that in a little bit also, but I'm trying to highlight this right away. All of these are derivatives. This is another category of subgraph. All of these are exchanges. Because all of these exchanges have the same database schema, we could send one query to all of these different subgraphs and get analyses from our query coming back to us from all of these different locations in Web3. So if I want to know, let's say, the total value locked of Curve, of Ellipses, of HoneySwap, of PancakeSwap, of QuickSwap, of SushiSwap, of all of these, Uniswap. If I want to know all of the TVL, I can send one query to all of these different subgraphs and get that data back instantly. And that's really the power of Masari subgraphs, in that they have the standardized way of organizing data, which allows us to build some really powerful things. Because really, with these subgraphs, having that standardization makes our lives easier. So we have to send, 50 different queries to 50 different subgraphs and try to figure out how is this data coming to us. This Masari standardization is a big deal. So now that we know if it's a Masari standard subgraph, it's a good subgraph, cool. The next thing I like to do is look at the curation level, the documentation, and the schema.graphql comments. Let's go ahead and find a different subgraph and look at the curation level and see what that means. So we'll go back to the Graph Explorer. And what is the curation level? Curation level is the amount of GRT on the subgraph itself. Basically, if there's more money on that GRT, there's more incentive for indexers to get to work incentivizing the indexing of that subgraph, as well as everyone gets more returns on that subgraph. If you're a curator or a delegator, there's a few other roles in the graph network, but essentially there's more returns from this subgraph. So this has 54.7K GRT, 205K GRT, a lot of GRT on that. So essentially that means that people out there are signaling and saying, hey, this data is valuable because we are willing to put our money on it. And then from there, they get returns. So generally speaking, those with more GRT on them are more valuable subgraphs, generally speaking. So that's kind of at a high level. We're looking to see if it's a Masari subgraph or if there's more GRT on it. We already know that these are quite valuable subgraphs. They're being used regularly. They have got a lot of GRT on them. What happens if a subgraph doesn't have the Masari tag? Or what happens if the subgraph doesn't have a lot of GRT on it? Well, let's go ahead and answer that question. Let's go and check out CryptoPunks. This was one of the first subgraphs I ever interacted with years ago with the Graph Network. It was this one right here. This only has 2K GRT on it. There's also one that is a CryptoPunks Masari subgraph. We already know that one's quality, but what about this one? This one has just a little bit of GRT on it. Let's dive in and see if we can find out if it's valuable. The first thing I like to do with the subgraph that I'm not sure if it has the data that I want is take a look at the documentation specific to this subgraph right here. Is this subgraph developer who developed the subgraph, is this a subgraph developer that took good notes, that has a good README, that helps me assess the subgraph? Well, right now, there's a good amount of words right there, which helps us understand what he's doing there. Let's go into the code a little bit as well and see about this documentation, and this documentation is good. So once again, a subgraph itself doesn't have to be, the subgraph developer, when they publish it to the Graph Network, they don't have to put their link there if they don't want, but it's always nice if they do, and then from there we could actually take a look at how their subgraph is operating. As we can see, the README is nice, which fills things out nicely. The thing I want to really only look at in this workshop is the schema.graphql file, which has these comments. And as we can see, this is how the database is organized. And these are the entities that we can query in this subgraph in the playground, as well as in our DApp. And then as we can see here, this is an account with the ID of a bytes type. And if this person did not put in this comment of the Ethereum address, this ID, we wouldn't know what that really was. It would just be, would send a query to the account entity with the ID field, and we would just get a return back. But with this comment, we know what we're getting back. We're getting the Ethereum address back. If we send a query to the account punks own the field, we know we're getting all punks owned by account. These comments are very helpful. So any quality subgraph, look in the schema.graphql for comments, for an explanation of the fields. And that's very, very nice for a subgraph developer to do. So let's go ahead and send some queries to this subgraph in respect to these comments. So we can go here and say, hey, we're at this CryptoPunk subgraph, and I want to send a query. Now, what kind of questions might I have with this subgraph? Well, I prepared some questions for this subgraph right here, where we can go ahead and ask ourselves, let's say, what are the first 10 sales in CryptoPunk's history? What are the first 100 sales between these timestamps? Let's go ahead and start looking at just these first two and say, all right, what are the first 10 sales in the history of CryptoPunk? So we're going to look at the entities. If we play with this little folder right here, we can actually play with all the different entities. And this is GraphQL, which is really nice about using this playground is just clicking around. We don't have to write code here. Every single entity is basically a bucket that we can query. A single entity, we have to put in the ID to query because we're looking at a single entity with a single ID, and that's a single sale entity. We want multiple. We want the first 10 sales. So we'll get the first 10 here. See, it's populating right there. And always, 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 I think it's good to have the ID so we know what ID we're getting back. And we want to know the first 10 in history. So we want the timestamp there. And then we're going to have to order it. We're going to have to order it by the timestamp. So we'll go here, timestamp. And then we want the order direction. And we want that order direction to be ascending. And so we can send that query. And there we go. We have the first 10 sales in the history of CryptoPunks. All right, so right there with this little query. So all we would have to do if we wanted to use this query in our application is take this query right there, copy paste it, and copy paste this, put this into our decentralized application, and start sending queries to this endpoint. And there's our API key that we just drop in that we set up in the beginning. So really, that is the workflow for this. The next query that we had was the first 100 sales between these two timestamps. So there's a little bit of logic here. So let's go ahead and look at this right here. And we'll go to, where am I here? There we go. We want to do a little bit of filtering. So if we go here, you see there's a little where. So that's a little bit of logic right here. Where, and we want to look for timestamp greater than. So we go all the way down here. Timestamp GT, timestamp greater than. Let me put on the timestamp. And then also we want timestamp less than. So we're kind of filtering through this. And where's the less than? There it is, right there. All right, where is it? Timestamp less than. So now we're filtering. You see this already populates right over there. And we'll get the ID and the timestamp as well. And now we've got a little bit of different data. All right, see how we have different. And we could actually go and get more fields on this entity. We could play around. We could find out, okay, well, you know, we have, where is it? Where is it? With the sales, and we want, what else do we want? We want the amount. Let's see how much was on each of these. And we can see the amount. Okay, we have a good amount right there, good amount right there. Very, very nice. Now, if we are here, remember how we had potentially comments in the schema.graphql. You see how a little pop-up happened on the screen that says punk being sold? If we hover our mouse over the actual field and it has the comment behind it, if there is in fact a comment, there'll be a little pop-up right there that we can see punk being sold. So that's really nice. We don't have to jump back and forth to the schema. If we just simply hover our mouse over the top, if there is in fact a comment there, we will actually see it pop up. And some don't have comments, some do. Transaction details that does, and this block number does, and block hash doesn't. Just a nice little feature if you want to know what you're querying. You just hover your mouse over it and you can see the comment just pop right up there. So nice little feature. So that is essentially what querying a subgraph is. We went through the 4 steps to understand a subgraph on the graph network. We have the Messari standard subgraph, the curation level, how much GRT is actually on that, the documentation, is there a good README, and then also the schema.graphql comments. That's really nice. When we send our comments, when we send our queries to the endpoint, we want to actually make sure that we understand what those fields are. So We designed some queries here. We answered some questions here. What's the total value of all sales? Because we're running a little short on time, I know we have an extra 30 minutes, but I have another workshop to get through. Go ahead, and if you want to design some queries on your own, send some queries to the contracts entity and see if you can get this information back. Really cool stuff. This is an example query to both of these Masari subgraphs. I just want to demonstrate this really quickly, where I designed this query to send to the curve finance subgraph, as well as the sushi swap finance subgraph. These are both exchanges. So if we have this curve finance subgraph and we want to say, hey, I want the TVL for this day, I just copy pasted that from that. We could design queries lots of different ways, but in here we got the total value locked for curve, and this exact same query to this other exchange can be sent. And that is super duper powerful to compare the TVL of two different exchanges on that same day. And we can create some really cool dashboards, analytics, lots of cool stuff that could be done with that. There's some more homework on this workshop. In that repo I sent you, there's this presentation too, so feel free to look through this in your own time. Here's a little bit more advanced query that goes to a different subgraph. This is called the 721 Tracker Ethereum. Feel free to tinker around with GraphQL. If you want to learn more about GraphQL and optimizing those queries, go ahead and scan this. This is querying best practices. As you get better in querying, querying becomes a skill itself. Using GraphQL becomes a skill. It's not just clicking. You have to think, like, how do I make these queries efficient? So that's really what optimizing these queries are. If anyone here likes using Python, this is a library that is dedicated to having Python interact with subgraphs. And this is called Playgrounds. Just go ahead and Google Playgrounds and subgraph, and you'll find the library. The library is called Subgrounds. Very well designed. And then if anyone likes to develop dashboards that connect directly to subgraphs, check out DappLooker. This is another company that basically says, hey, if you don't want to code these dashboards, just point our system towards subgraphs, and these dashboards will just create for you, which is very nice. And then finally, the takeaways. Asking great questions really is the start. So before you get going into the graph, think, which Web3 community do I want to go look at? Do I want to look at Exchange? Do I want to look at NFTs? Do I want to look at DeFi? Do I want to look at governance? Think about the questions first before starting to ask the query. That's really important. Decentralized indexing, the graph is really production ready for all of Web3 in a decentralized fashion for indexing. There are other indexing solutions out there that are centralized. We are very proudly production ready for decentralized indexing. 2,500 subgraphs are ready for all of us here. Go find subgraphs in the Graph Explorer and play in the playground. So once again, that repo I sent over. We have a Telegram group. If anyone wants to join it, this is the Graph Hackers. So any questions that you might have, feel free to join that. And I write the Graph Builders newsletter every single month. So that's for the builders like you guys. So once again, this is all in the presentation in the repo. If you are missing on these scans, I'm sorry about that, but I'm trying to respect time here. And then here, if any of you guys are building smart contracts and want to index that smart contract on a local computer, this is a great blog to go through, where it essentially has you using Scaffold ETH and the graph at the same time, and it designs it through Docker. Very nice blog through that. So thank you. That's for this presentation. I'll stop right now and wait for questions if anyone has questions for this. But for right now, let's stop. I'll stop sharing for right now. And if there's any questions, I'll stop right now before we get into the next presentation where we learn to build some subgraphs.
One question is, like, what's the difference, like, with the graph with the Dune Analytics? So
great question. Yeah. Well, starting from just first glance, Dune Analytics is centralized and the graph is decentralized. So that's the biggest difference. The other difference is that because that we have a publicly accessible way to interact with subgraphs, we have a lot of options in terms of data transformations. We have a lot of features that we can use, specific and very granular ways that we could actually make the data coming from the chain more valuable before displaying it in a very customized way. We're doing, of course, there's customizations, but subgraphs really can get quite detailed. And those are the two biggest differences, where yes, Dune does have dashboards and analytics, and that's great. But it is centralized, and they do have a model that can be quite pricey. So I think personally, I think the graph's values of decentralization in the stack is quite important, and then also the affordability for right now. $40 per million queries is very affordable, and the customization is quite good too. Great question. Any other question?
Another question. So I noticed that auto query is done through the website or gateway from the graph.com. So we're just curious, like whether there's other way to, for example, I can set out a node by myself and then query by using the node, or a more decentralized way. Yeah.
You totally could. If you want to set up a node yourself and basically become your own indexer, the software is available and you could do it at home for yourself if you want to. You don't have to, because the graph is there to do that work for you. But a lot of people do enjoy running their own indexer for their own data. And that is something that you could absolutely do. So you essentially, spin up Graph Node, which is the indexer software, and then you design a subgraph on your local computer and then connect the two. And then from there, you're doing it all locally. And that's totally possible. Yes, I see a thumbs up. Cool. All right. So if there's no questions anymore, and by the way, feel free to interrupt. If anyone has questions, throw it out there. I'm happy to chat. And by the way, Yo-Yo, do we have a hard stop at the hour, or can I go over a little bit? I'm just curious.
Of course, you can go as long as you want. Yeah.
Okay.
No
cool.
problem.
Cool. I saw the booking for 1 hour, so I wanted to be
No.
Okay. Cool. Yeah, 25 minutes to go over subgraph developments is cool. It's a lot. So cool. Let's go ahead and go into the next workshop, where we're going to learn how to develop a subgraph on our own. And we'll close these. And this is the subgraph development workshop. Okay, so this is the previous, I sent 2 links. This is the other one that I put together. So really quickly, what we are going to do in this workshop, of course, we've already gone over what the graph is and also what are subgraphs. And so we could skip those first 2 parts. We're just going to go right into deploying a subgraph and then comparing queries with 2 different subgraphs. Our subgraph that we just deployed, which is kind of just a boilerplate starter subgraph, and then a more advanced subgraph that has more features to it. Remember, I talked about customization about these subgraphs. Okay, there we go. And so to see a subgraph with more features, more customization, what does that unlock? That's really important. And it's really good for learning to have a subgraph that is a little bit more advanced. So we can say, hey, this is a basic subgraph. This is more advanced. What is this subgraph that's advanced, and what is it doing differently? It's a really good learning opportunity. So let's get into it right now. Let's go ahead and start. We're going to stay on CryptoPunks, the subgraph that we were looking at previously. I like to stay on that in terms of workshops and continuity. We're going to stay with that. We're going to look at the same one and see why it's a little bit more advanced. Remember, we talked about the 3 files, the subgraphs, the mappings, and the subgraph.yaml, the manifest. We're going to go through all that and really understand what the purposes of each of those files are. Okay, so to start, if anyone here would like to do this with me, feel free. That we're going to all do this together. I'm totally fine taking the time and doing this. We'll just start at the graph.com studio. If you just want to watch, that's totally fine too. But we're going to spin up a CryptoPunks subgraph, all of us together, if you guys would like to join. So we'll just go ahead and go to the graph.com/studio. And of course, you'll need to log in with your wallet. And if you haven't done that yet, go ahead and do that. I'm just going to keep on going through here. We're going to create a subgraph. I'm going to call this a Web3 Builders Live Demo. Okay. I'm going to create a subgraph. And this is the subgraph's dashboard. All right. When we spin up our subgraph on our local computer, it will be, when we deploy it, it will be reflected here. And we'll talk about that a little bit more. We have all the information that we could put into the subgraph. We could give it a description. We could actually put the GitHub URL in there, the website that the data is populating to. We can categorize it. The purpose of all of this is to actually put this information here just in case we eventually do publish this subgraph to the Graph Network. Now, really quickly, I want to differentiate Anytime we spin up a subgraph and deploy it to Subgraph Studio right here, this is not on the graph network just yet. We can iterate it, we can do more local development, we could do multiple deploys and keep it in just the Subgraph Studio environment where it is not being on the graph network. It is not a public subgraph. When we are ready, we can go ahead and click on publish, and that will actually get it sent to the indexers around the world. And we could have various versions that are just in Subgraph Studio, and we could have various versions that are on the graph network. It's nice to think of Subgraph Studio really as like a development environment. We could have many different versions and tinkering and playing around, and it's all private. We don't have to share this subgraph with anyone. But as soon as we click on publish, that does become public on the graph network. So these could be more production subgraphs that are not rate limited. These are subgraphs on the graph network with more features out there. Here is just a rate limited environment just for development. Just showing that difference real quick before we get into this. So first things first, if you haven't already, install the Graph CLI, and you could just copy paste this into a terminal of your choice. I've already installed this in the past, so I'm not going to install this currently right now. But what we're going to do then is just copy paste this. We're going to do graph init. All right. So graph init is the way we spin up a subgraph. And we need to think, okay, we're going to be indexing CryptoPunks. So make this a little bigger. There we go. Which different chain system are we going to be indexing CryptoPunks on? It's not Arweave. We know it's Ethereum. Near is non-EVM, and Cosmos non-EVM substreams is a whole different tech. So we know we want it to be Ethereum. All the EVM chains will be here. We automatically populate with the subgraph slug that came in from the CLI's initial command. And then that's fine. Just fill that in, the demo. And then from here, we look for the chain that we would like to find our smart contract on. Now, we have over 40 different chains here, lots of test nets and main nets. We just want mainnet because we know CryptoPunks is on Ethereum mainnet. So we'll just select that. And now we need to find the contract address. So let's go ahead and go to Etherscan and look for CryptoPunks and find it. Okay, so here we have CryptoPunks, and we want to look for the actual contract. Yep, CryptoPunks market. So that's what we have right there, which is awesome. The etherscan.io, there is the smart contract address, ends in BBB right there. And we have that ready to go. Okay, so once we have that smart contract address, we of course could just drop it right in there. Nothing wrong with doing that. I'll do that right there. Sometimes due to Etherscan, it will fail to find the start block. That's okay. That's an Etherscan thing. We're pinging Etherscan for this. We just keep on retrying until we find it. And then the start block, we want to select the start block that we want to start gathering data from. It automatically finds the start block where the smart contract was initially deployed. So it finds this start block. If we need all the data from the history of the CryptoPunks smart contract, we select that. If we only need recent data, we can actually say, hey, we don't need all the way from the beginning. We just need more recent. But we'll just select that just because that's fine. It's good practice to name the contract the same name as the contract name, CryptoPunks Market. And that's just a good practice. You don't have to do that, but that's good practice. Another reason why that's helpful is because one subgraph can index multiple smart contracts on the same chain. So if they're all named contract, that's not great. So try to name it the name of the smart contract. And then from there, index contract events as entities. This is really the cool thing about subgraphs. Subgraphs specifically index events. So anytime we're in the smart contract and we see an event right there, all of these events right here, these are the events that we're going to be indexing. It doesn't index all the different internal transactions or transactions as a whole. It's specific to events. So just know that when you are either designing your smart contract or thinking of a subgraph, think of the events as the valuable piece that we are indexing for our subgraph. There are other technologies in the graph ecosystem that allow us to index the internal transactions, all the transactions, but they're more advanced. We'll just start with subgraphs right now. So let's go ahead and index these events and create entities, which are entities within our database. Basically, it takes the exact same name of the event, the assign event, the transfer event, the punk transfer event, and it will convert those into locations of storage in our database. So I'll select true. And it's spinning this up locally on my computer. Excuse me. And it's doing its thing. While this is doing its thing locally, I just want to point out one thing. This is a really nice developer tool for subgraph developers. This is called Miniscan. If we go ahead and drop in CryptoPunks Market, we need actually a contract address. I really, really like this. Here it is. This Miniscan. There it is. Because what this does is it gives us a lot of good, we want Ethereum, subgraph developer relevant information pretty quickly. And it's given it to us right in front of us. We have the name of the smart contract, the start block, if we need it, the ABI, the actual code of the smart contract, all the different events. This is all really quickly right in front of us. And so we don't have to go through Etherscan for this and tab, tab, tab. It's just right there. It's miniscan.xyz. Someone out there, I think on the Messari team, designed this. And it's a really helpful little website for subgraph developers. So let's keep on going. And there we go. Generate, do we want to add another contract? We will not. We'll say no. We could run through these next steps right here. But what I like to do, just because it's a little bit quicker, is actually go to copy paste these. So we authenticate our computer. Just make sure this authentication key is kept private, because this allows any computer that has this key to interact with your subgraph, which you wouldn't want them to do. So copy paste that into your computer. I'm not going to do that because I've already authenticated my computer in the past. We're going to enter the subgraph. So just copy paste that. Graph CodeGen and Graph Build. Let's go ahead and do that. Graph CodeGen creates type safety, creates all the types, and Build is the compiler. And then from there, we are ready to deploy. So before we deploy, I want to go ahead and take a look at the code. All right, let's go ahead and dive into the code real quickly. And here we have our boilerplate subgraph. Already, it is ready to go. So this is really cool. The first file I want to take a look at is the subgraph.yaml. The next one is it's in the SRC folder. We call this the mappings file, but it will change its name actually depending on the smart contract name, CryptoPunks Market. That's the name of the smart contract. We just call those the mappings file because it does the transformations. And then finally, we've already been over the schema.graphql. So let's go through this here right now. Subgraph.yaml. This is the manifest. This essentially gives us a high-level overview of what our subgraph will be doing. So it's a good place to start to understand subgraph development. We have a data source here. Oh, this is cool. This is a new feature that just came out recently, I think like a month and a half ago. Essentially, if there's old and stale data in the subgraph, it automatically prunes that data from the subgraph. It's not being used. And that's a really nice feature. It keeps the subgraph light and quick, which is very nice. Let's just take a look at data sources. Okay. All that information that we put in the CLI is right here. We have the start block. We have the ABI that was gathered by Etherscan. We have the smart contract address. We know it's Ethereum mainnet. We have the name, all that stuff we put in there. And this right here are the entities in our database. We have these, the assign entity, the transfer entity. This is what we will eventually be querying with our queries. Now we see down here, these are the event handlers. Now, really quickly, what this means is anytime an assigned event is emitted from the smart contract, it triggers the handler to fire. And this is the handle assign handler, okay? Anytime a transfer event is emitted from the smart contract, it triggers the handle transfer handler, and so on and so forth. This was automatically spun up from the subgraph. When you get into subgraph development, you may be messing around with these a little bit and saying, hey, if this event happens, let's trigger this handler, and just getting more aware of that. And then also defining other entities. If we want to add entities, we can add them here. If we want to take away entities, we can take them away here. But anything we change here, and the entities, of course, has to be changed in the entities here. These are all entities in our database. So if we update these entities, it must be correctly reflected in the actual schema of the database itself. So these are just the names of the database. These are how the events are being handled. And essentially, that's the manifest. Gives us a high-level overview of what's going on. Let's dive one level deeper. Let's say, okay, we have this assign event that's being emitted from the smart contract, and it's triggering the handle assign handler. That is going to be in our, remember I talked to you about the mappings file? We have the SRC folder right there, CryptoPunks Market, right there. So let's see right here. This is exactly the boilerplate that is occurring. This is the handle assign handler that is being triggered by the assign event right there. So we can see the events coming through. It's being passed into this function, the handle assign. And this is essentially what happens on every single handler. This is kind of a high level understanding of what happens on every single handler. This is what's going to go on. Initially, a new object is created right here. This entity object is created, and it's of the type of whatever that event is. So it's the assign event, all right? So the first thing that we pass is going to be the ID. And this ID is really common. We want to have a unique ID. So this is just going to be a transactions hash, this exact transactions hash. And it's going to be concatenated with the log index. And this creates a bytes object, which is a very unique kind of way of creating an ID. This, of course, could be changed to a string. It could also be changed to an I32, I believe, but the best is bytes in terms of just performance of the database. It's best to always have your ID be of bytes if you can have that be true. And then from there, after we have the entity of the type of the event and then ID passed, we're ready to take the event data. We have the event right here, and we're passing all the events data, the event 2, the event punk index, the event block number, and passing that into the database. We pass that into the entity 2, entity punk index. This is the database right here. And then this is the event, as we can see. We're simply just passing it right into it, and then we save the entity. That's all this is doing. We're just simply taking what's the data is coming from the event, and we're putting it into the database. Now, this is where the advanced techniques can come in, because this is assembly script. It looks like TypeScript. But if we're thinking about doing any type of transformations with the data, if we want to do any types of compute, if we want to go ahead and take information from one handler and bring it to another handler, if we want to go ahead and start playing around with the data, we can do that. And then that becomes really customizable very, very, very fast. So what does that look like? Let's go ahead and take a look at this subgraph. Remember this subgraph, guys? The CryptoPunks subgraph from Mr. Jerry Okolo. Let's take a look at this subgraph, take a look at his mappings and the creativity that's going on in this file here. So we can see this person, Jerry, has done a lot of extending of this subgraph. He's not simply going through and passing the event data and then going and putting that in the database. No, no, no. He is looping. He is going ahead and writing. There's comments everywhere. There's helpers going on. This is where subgraphs really can shine. When you have a good subgraph developer out there thinking, we've got good crypto data. What do we want to do with it? How do we actually take this data from the very beginning of the smart contract to this very second and start transforming all of that data into useful ways? Go ahead and dive into this subgraph, because this subgraph right here is indexing the exact same data that this subgraph is indexing. So we can say, hey, well, all we're doing is taking the event data and just simply passing it to the database. Well, with Jerry and his subgraph, there's much more going on. So I'd recommend, if you guys want to learn more about subgraph development, see what Jerry is doing with these mappings and how he's populating the database, and why he might be doing it. This might be a good one for, Control A, select everything, drop it in a chat GPT and be like, hey, what's happening with this event and what's going on here? It's a really good way to learn. Subgraph development is just simply take a subgraph that's very simple, like this one, and take one that's more advanced and go back and forth and see if you could extend your simple subgraph. And if you see a cool feature in this subgraph, maybe learn this feature and be like, why is Jerry doing this? Why is Jerry putting, there's so much here. It's hard to go over in just a few minutes. But anyways, this is the workflow that how I learned subgraph development is I started with the basic subgraph, and then I looked at a more advanced subgraph, and I went back and forth and back and forth. Why is this person doing this? How is this going on? It's a good way to learn. So that is really the overview of subgraph development that I want to start with, we can go ahead and look at the Punk transfer event specifically. I think that's a pretty cool one. And we've already deployed. Oh, we actually didn't deploy the subgraph already. Let's go ahead and deploy this one. Of course we haven't. Let's go ahead and deploy it and take a look at it. Where is this? Of course we have to deploy it. We're in Subgraph Studio. Let's deploy our subgraph. And we'll be here. Graph deploy. Okay, give it a version. And it's compiling, uploading the file to IPFS. So the indexer can grab the manifest and then start indexing. I'll actually drop this subgraph into the chat. Where is Explorer? This is the subgraph I really learned how to become a subgraph developer with, and I went back and forth a lot. So I'm trying to share with you my type in chat. Here we go. This is the subgraph. Hopefully everyone got that. Yeah, feel free to go to the repo here as well. Let's copy link address. So let's go ahead and go back to the studio. We are having, okay, that's okay. Unfortunately, this is actually a little bit behind the scenes. We were having an issue with IPFS literally today with the graph. So hopefully this goes through today. If not, that's okay. I have another subgraph that is this exact subgraph from previous workshop that we could take a look at. IPFS was not happy today for whatever reason. We were trying to interact with it. So let's go to our studio. And here we have, I was doing a workshop actually, I think last week. I also did CryptoPunks for them. So we can see this subgraph was indexed. Let's see if this went through. Yeah, IPFS was having difficulty with us today. So unfortunately, this is a IPFS was troublesome. I'll keep on trying. Hopefully that goes through for you guys today. But anyways, our subgraph right now that was deployed last week is of course working right now. The queries that we worked on before by going through Explorer, if we look at the events that were coming from the subgraph, these are all the events. These have been converted into entries in the database, and we already know how to query these. I didn't go over saving queries. That's this little button here. Any queries that we've ever set in the past, we could actually have that in our history, and we could save those queries. We could rename the query and say fave query. Very nice little convenient features if we're designing queries regularly. We can name these queries and say, fave query and save it as a new. It's just nice to have these different abilities to save and tinker with a subgraph as we are going through it. So what I would do for you guys is, like I said, learn a boilerplate subgraph and then learn a little bit more of an advanced subgraph. How is the database being managed in the schema.graphql? How is the mappings being managed? And then go back and forth and see if we could extend, use ChatGPT. That's always quite helpful. And then what I want to also do is bring up a few other interesting points here for just kind of an idea that I want to plant in your head. So whenever you're designing your schema.graphql file, essentially you're designing your database. What you're going to want to think about are, if you want to go beyond just logging events, you want to start thinking, okay, what are good entities that could be aggregating lots of information into this one entity? And I think this is a good idea for, if you were indexing an NFT, such as CryptoPunks, we're going to probably want to have a custom entity that we design, a contract. Let's see who's in this contract. What's the address of this contract? The counts, how the total going through this contract, the owners of this smart contract. This is just a good entity to design. And you could actually work on building this yourself and say, all right, well, take a look at how Jerry did it and do it yourself. See, the account represents the owner. And the current holdings of the owner's NFTs and what the values are. That'd be a cool one to design. The NFT itself. Do we want to understand the CryptoPunks NFT? What's being passed around? How much value did it have on January 1st of 2020 or 2022 or something like that. That's cool. The event interface, being able to understand what event is going on. Is it a transfer, a mint, a bid, ask, sale, more details about the event itself, and then the metadata. Off-chain data through IPFS can be indexed through what's called a technique called file data sources. There's a blog that I wrote about file data sources that's out there. So please check that out if you want some IPFS off-chain data. Another thing about the schema, ideally, if you're just logging data from events and you're not going to be changing that entity, leave it as immutable. Don't change it from that. And the purpose of that, we can see here, these are all automatically immutable events because these are all truly just, these are all, excuse me, all immutable entities because they're just logging data from the chain. If the data coming from the chain, if we plan to create another entity, we'll say type, excuse me, we'll go here and we'll say type accounts. And with this, we know with this accounts entity, we're going to be changing this entity and building it out and extending it more. It's not going to be logging data. We're going to be transforming data here in the mappings and then populating this custom entity. We won't make this immutable because we're going to be changing this all the time. If we make this immutable, it makes it much more fast with indexing and much more performant as a database. So custom entities, not immutable, just the logging of event data, keep that immutable. And aggregation, we already kind of talked about this, where aggregating, bringing all the important concepts into a single entity, that's really nice. And then also there's relations that we can do. We can derive relations, also derive from one-to-many, many-to-many relationships. That's also possible. Yeah, we talked about this, linking entities, reverse lookups are also possible. These are all cool things that we could do with the data. Get or create helpers, basically we check in the database. If it is there, we go get it. And if it's not there, we create that entry in the database. Assembly script as a whole needs null checks. So this becomes a regular helper that's used in a lot of subgraphs. So here's a few other tips and tricks. Avoid ETH calls, essentially sending an ETH call to the Ethereum node will slow down our subgraph, because if our subgraph needs data that's not an event, it's coming from an ETH call, our subgraph has to stop. And then from there, wait for that ETH call to return from the Ethereum node, and that just slows down indexing. So if we can avoid ETH calls, please avoid those. Call handlers, avoid those as much as possible. Linking is good. Document the schema well. Those are the comments we talked about earlier. And this is a big one. Omit all information from the smart contract. If you're developing a smart contract, omit all that information from the events. Really have some good events. That's a really big deal. So if you guys would like, please compare the two subgraphs. Compare the CryptoPunks subgraph that you have deployed with the subgraph that Jerry has deployed, the more advanced subgraph. And many of these questions could be answered by just the basic subgraph that we spun up. Some questions cannot be answered by that subgraph. And so you'll have to kind of think about, how can we answer these questions? Go through the subgraphs, go have some fun, answer these questions, play with maybe ChatGPT, throw the schema in there and be like, hey, I got some questions. Like, start learning about this. It's pretty cool. So finally, I did mention this, Scaffold ETH2 and subgraphs. This is the same blog entry I talked about previously, where if you want to build a smart contract and connect that directly to a subgraph right away from the beginning, and then also have a front end that's boilerplated up, this is a fantastic way to get started. And that is the entire workshop. So I'm on Twitter as Marcus_Rain_. If anyone out there wants to follow me, I'm available to help developers build with subgraphs and get to know the graph network as a whole. And I really appreciate everyone's time here. And I want to leave things open for questions, because I went over a lot of information to getting aware of the graph network, as well as getting aware of building a subgraph and just beginning the process of learning, comparing a basic subgraph to a more advanced one. So I'll stop sharing my screen, and I'll leave this open for conversation. And I want to thank everyone for coming back for this presentation. I feel terrible about missing last week, but you know, time differences and everything. So anyways, if there's any questions, I'm here for you.
Yeah, one question is how long it will take to index the whole chain data. Suppose I like submit deploy a new for example, the source file. So
Like a
almost
CryptoPunks.
need to, uh for example for general any contract like
Yeah,
yeah, it looks like
yeah.
depends on how long the contract has been deployed. Yeah.
Exactly. Yep, you hit the nail right on the head. A subgraph is a set of instructions that if we say the subgraph should only index today's from yesterday's start block to today, it'll literally take a second. But if we want to go from the very genesis block, from block zero, from the very beginning all the way till today, the chain might be years and years and years old. It just depends. And then also if there's going to be more advanced techniques, let's say there are ETH calls, and I said, please avoid ETH calls in subgraph. I've seen subgraphs with dozens and dozens and dozens of ETH calls. That could take a month. I mean, that literally, if there's lots of ETH calls that you're doing in your mappings, it's a lot about subgraph design. If you design it efficiently, and you kind of learn a little bit more intermediate techniques, it can go much faster. So it depends. It depends on the instructions you send to the indexer. If they're well-designed instructions and you're accurate in using immutable entities when you should and having bytes as IDs, that really makes a big difference in the indexing speed. So I can't answer that because data is data. And if because these subgraphs are so dynamic and so customizable, it ranges. But if it's well designed, like for example, one of the biggest subgraphs that I've ever seen is now the Uniswap subgraph, and that's actively being used in production every single day. It used to take months and months to index. So any one change would, take, I think, like 4 months to get all the way through, which is crazy amount of data. A new technology was released this last year where it only takes a few days now. So we're always looking to improve indexing speed. We're always doing our very best. The new technology is called substreams, which is way more advanced than subgraphs. We don't need to get into that today. But yeah, if indexing speed is a concern to you, it's a big concern to us too. We want it to be fast.
Cool, that's awesome. I'm just curious, like whether this index speed is related to some graph token, maybe
Ooh.
DeepSeek or something put that there. Because like looks like I can submit a lot of indexing and how to prioritize all those index tasks internally in the graph network.
That's a great question. And yes, you're absolutely right. The more tokens there are on a subgraph, the more indexers are incentivized to index that subgraph. And when an indexer jumps in to index, let's say there's two indexers that are both indexing this one subgraph because they both want to get paid. Well, that's great. We have a backup in case any one of them fails for whatever reason. That's the whole point of the graph network, to have all that redundancy, to have 5 indexers, 10 indexers. There's a gateway in the graph ecosystem that right now is centralized. We're doing our very best in the next year, we think, maybe 2 years, to actually have that decentralized too. We're trying to decentralize every part of our stack. But essentially, that gateway determines the most performant indexer for that query. It looks how close that indexer is to the person sending the query. It looks on how quality the indexer is and how good they are returning the data, how quickly they are, how performant their system is. So it is competitive for indexers. The more indexers that are indexing a single subgraph, yes, it is incentivized by the token. And sometimes there's subgraphs with 15 indexers, 19 indexers. It's competitive. So yeah, it is affected by the token, and that we like that. There's a marketplace that people querying the graph network win. People that use the graph network win because the indexers want to get paid. Good question.
Yeah, that's awesome. Probably last question is like, suppose I accidentally wrote the indexing script with like, for example, forever loop or really, really heavy. How, how would that like preventing attack to the network? Like how would the network like attack detect this like gas metering similar to EVM, right? So is the
Yeah.
graph a similar design to avoid this kind of like heavy indexing or forever loop?
You know, I don't know the answer to that question. I myself am not an indexer. I've been to indexing meetups and I've talked with them. I have never actually jumped into the graph network and been an indexer. I've always been a subgraph developer and building dApps. It's a very good question, though. I am not sure. I do not know what would happen. I do know that there's a slashing mechanism for indexers if they do a not a great job. Let's say that they lose money, and so there is pressure on them to perform. So typically, if you're an indexer, all the indexers I've met are very good developers. They are experienced because to be an indexer, you have to know how to run multiple pieces of hardware and software and how everything interacts and learn about the graph network. There, you got to be talented. So uh, it's not like they can't write a infinite loop. I'm sure they could, but they're quite good, and they know what they're doing. Great question again. I'll have to ask. One of my friends is actually we chat almost every few days. He's a very good indexer, so should ask him that question. What happens if you write a infinite loop in the indexing?
Any more questions? Yeah, if like no one has more questions, then yes, very thanks, Marcus, for joining us. Yeah.
Yep.
Thanks everyone
Awesome.
for coming. Yeah.
Thank you so
So
much
it's
for
the end of
coming.
our sharing. Yeah. So all our records will be like upload to YouTube and Bilibili and also our WeChat. So yeah, thanks everyone for coming. We'll see you next week.
Thank you everyone for having
Bye.
me. Thank
Bye.
you so much.
Bye.
Bye
Bye.
bye.